Here are the answers to assignment number 5. And most of the work is shown, so I'm not going to be doing much explaining. In this case, you take the component f cos theta, which is going to be 17.32, and then add it to 20 newtons, so the total is 37.32. And then acceleration is the net force divided by the mass. It gives you 7.46. In this question, looking at the forces acting on this mass, it's Ft minus F, because it's in the opposite direction, is 2 times m times a. And then looking at the forces acting on this mass, it's mg minus Ft is equal to ma. Now multiply equation 2 with 2 and subtract from 1. And all the work is shown, and it's a lot of algebra there. Just make Ft the subject and you get 23.1 Newton. Question 3, you're asked to find the resultant force, so there must be the centripetal force given by mv squared by r, which is 600 Newton. And then you have the weight of the object, which is 735 Newton. And since they are at right angles, the square root, sum of the squares of the two, that'll give you the resultant force. In question 4, at the lowest point, Ft is up, mg is down, so Ft minus mg should give you the centripetal force. Rearrange to make Ft on one side and substitute the numbers to get 40.9 Newton. In number 5, the force is acting at 20 degrees and the component is 15 cos 20, gives 14 newtons, and work is just the product of that force along the direction of displacement with the displacement, that gives you 84 joules. In number 6, the kinetic energy far away from the spring should be equal to the sum of the kinetic energy, the new kinetic energy, plus the potential energy of the spring. The halves are crossed out, and if you take the mass as 1 kilogram, then obviously you get 36 is v prime squared plus 45. That gives you 36 minus 45, which is negative, and that's impossible. Therefore, let's take the mass as 2 kilograms. Just to give a more realistic answer. It's 2 kilograms. Then get 72, because this quantity is now going to be 2 times, because there's going to be 2 here, 2 times 36, that's how you get the 72, and the minus 45, which gives 27, and then take the square root of that to give 5.20 meter per second. In number 7, work is force times distance or displacement, but displacement is velocity multiplied by time. So it's 10 meter, and work is force, which is in this case is mg times d, because you're lifting it, which gives 196 joules. 8. The kinetic energy plus the potential energy at A becomes equal to the kinetic energy at B. That is just before it hits the ground. And here are the formulas. Plug in the numbers. To get the kinetic energy at B. That is 576 plus 3920. Oh. Another look at this. And I surely made a mistake here, so it's 392. Hold on, it's 392, so 576 plus 392. And that gives 968 joules. I just got that mistake at the last minute. Anyway, number 9, the time period squared is equal to 4 pi squared by gm times r cube, and rearrange that to make mass the subject, and you get this formula. And I forgot to put in the g, which I'm going to add. Must be a g here. Okay. B. Now, so g is 6.67 times 10 to the negative 11. You add all that and calculate, you get 4.29 times 10 to the 28 kilogram. And the last question, g is gm divided by distance squared. But here the distance is 4 times the radius of the earth. So it is just a matter of putting in the numbers now. And the kilometer has to be changed into meter. And you get 0.613 meter per second squared.